Hello, everybody. Thank you very much for joining today. So, today's session will be all about application security 101. But at the same time, you can think like it's going to be a fundamental language that we can speak for all security matters because it will be covering most of the things. So, this session is designed to create the same language, same understanding, and same experience as security engineers, and everybody can understand security very well, and then build on top of it everything related to application security. So, in security, we have many things that can be important. But if we need to summarize and speed up everybody to understand security concepts, security is a matter that of a balance, not too much, not too less, only adequate security. So, if your security is too less, it's going to be a horrible for managing risk. But if you put everything to be secure, like a castle needs to be defined or defend, so it's going to be hard to use for users. So we need only adequate security, not too much, not too less. What about the second one? So the security is about your residual risks, not what you have prevented. Because in the wild, hackers don't care about what you have prevented so far. It's only about what you couldn't or you missed. So residual risks mean that the things after you have done everything for security as a residual remaining part of the risks. In that part, we have two things as a reminder: adequate security and residual risks. So if we understand application security domain, we will look at today software development lifecycle and especially how we can secure software development lifecycle as an index, the big picture of appsec, components, and shifting left principle. And lastly, we will touch little about non-attack surfaces and vectors, like what is all about Rust vulnerabilities, what is all about substrate vulnerabilities, or what about ink vulnerabilities. But we will have another session next week about most detailed version of top common security risks about substrate and Polkadot risks with code examples. So let's get started. Securing SDLC. So this is the big picture of application security. So we will visit this picture multiple times in the terms. But if you look at it's very generic. It's not designed for any kind of products. But if you look at, there's a client, there are some needs, there are some processes in the companies that needs to be done. If you do things early on the process, that means you shift the left. If you do the things at the end of the product lifecycle after the release, that means you shift the right. So you could do shift right by making some penetration testing at the end of the product lifecycle, or you could do risk assessment, security requirements, threat modeling, and many things by shifting left. On the middle, there are some other process we can discuss. But the whole idea is where are you in the picture here right now and what you could do with the things you have by today. So security needs to be enforced by controls, but the security controls at the same time must be designed, developed, implemented, configured, operated, monitored, and improved. So we cannot just put a security control and forget about it. So we need to think about it as a living thing. So, okay, there are some security controls we can put on our code, but how do we decide on controls? So it's all about risk. As we discussed before, to understand residual risk, we need to look at what is risk. So risk is very basic. So the likelihood of threat exploiting a vulnerability and thereby causing damage to an asset. But risk is everywhere. There are some risks we can see and there are some risks we cannot see, but we can try to protect ourselves from unknown. So, to be on the same page and with the same language, there are some risks can affect our confidentiality, integrity, or availability. In security area, we call this as CII threat. So, we need to ensure confidentiality, integrity, and availability within our applications. But what are those? So, confidentiality ensure that only authorized people can access their authorized entities. And integrity is the same concept with another point. Ensure that only authorized changes are made by authorized entities. Availability, same concept, but looking at the different angle of the triangle. So ensure that the data will always be available when it's required. So, is that all? Of course, no. When we cover confidentiality, integrity, and availability, we need to do some more things to add some things that can cover everything about application security and also security. So our applications probably will need authentication, authorization, accountability, and non-repudiation. Authentication is all about who you are, and authorization all about what you allow to do with your identity. And accountability, who is the responsible, the actions have been done. And non repudiation can't deny your involvement. If you do something wrong or good in the application, you could be able to see the logs, the non repudiation things related to the identity to see who, do what, and how and when. All right, so those are the general concepts when we think about security or try to implement security to our applications. But is it all? Of course not. So we need to look at the design principles as well. It's going to be, I will try to explain with some pictures and with concepts. But of course, we will have a small Q&A session if you have any questions about it. So the first thing, it's all about good enough security. So if you would like to spend $10,000 to protect $20 bill, it's going to be a problem. So we need to understand how much value we create within our applications and how much effort we need to spend. So we need good enough security, not perfect security, because in security, there is no such a thing like perfect. What about this privilege? So it's all about don't give your safe key to everybody, give only what they need. If, of course, there are some cases we can see from the wild about this privilege, but if you start from beginning, if you just give only the authorization or access to people only what they need, it's not going to be a pain afterwards. Because when you try to scale your company or scale your security or application, it's going to be a worry. It's very easy to do this with 3 people, but imagine like you have 10,000 people needs to understand their privileges, or million or billion. So another one is separation of duties. You just need to understand, or we just need to understand, don't give the power of creating invoice, approving invoice, and sending money to one person. In this case, they can create invoices, they can approve invoices, and they can send the money. That means there will be an issue to impact the CII triad. So we just need to separate the duties and important duties between the parties, between the stakeholders. Defense in depth. So if you look at any castle, you can see there are some moats, thick walls, restricted access points, high points for defending, monitoring points, multiple checkpoints, first door, second door, maybe third door. So in the application security area, what do you have? What kind of defenses in depth, step by step, protect your application? And another one is failsafe. Any function that is not specifically authorized is denied by default. It's a little bit controversial and it needs to be evaluated by application and the business case itself. Imagine there's a room and there's a fire door. Imagine the door is working like if there's a fire inside, you can go outside, but you cannot go in. But one of the presentation, I had a very good question about it. What if there is someone needs help from outside, inside of the room? Maybe he passed out or she passed out. So the design itself shouldn't be blocking the needs of the application or the critical functions of the application. Of course, we need to be secure, but we shouldn't be blocking anything inside the functionalities because security itself is a non functional requirement, which means there are two requirements we will discuss. So security is a supporting function for business, not the business itself, unless you create a security product. So economy of mechanism. Keep it simple and stupid. Security is already a complex topic, and we don't want to make it more complicated. So if you look at here, I do live in London, and you can see that we try to protect our bicycles like this. It's not going to be sensible things, right? So if you have 100 pounds of bicycle and bike, if you want to, if you spend, it's related to first thing we see. If you would like to spend many money to protect it, it's not going to be a sensible thing. So keep it simple and stupid, because security doesn't like complex topics. So, complete mediation. Every critical operations must have verification at every time. You can see this in some banking or financial transaction applications. So, when you open your phone and authenticate your biometric, you can open your application. But when you open your application, every time in your mobile application, for example, any banking application, you just need to provide a biometric or a PIN or some kind of password to open your application. This is the a good example of complete mediation. But when you open your application, when you try to send money, let's say more than £1,000 or $1,000, you just need to do this or provide another security function to complete the mediation. So every critical operations must have verification at every time. Imagine if you lose your phone and when they bypass your biometric, for example, it's going to be a problem. So open design. Many years ago, security depends on security over obscurity. So in the security area, very early time of the security, we could see there are some things security over obscurity. Especially after Kerckhoff principle in cryptography, security has been evolved to more likely it should be the design itself, it should be the open one. But if we would like to do the security, we just need to secure our credentials, maybe passwords, maybe encryption keys, but the algorithm itself should be open source. If you are not protecting some kind of special design will allow you to go to the Mars. I don't know. Sometimes you need to protect your uh, private information as well. But the designs as well shouldn't be rely on obscurity for security. So this common mechanism, it's like the rarest key open specific logs, but not used often, but still can cause significant damage when it does. So there's a controversial thing in security. If you remember this concept, we think like, okay, we need to use many things we use already. For example, libraries in programming, right? You don't have to invent mathematics or special number theory for your codes. You can use libraries. But when we use common mechanism for everything, we also create some kind of risk for applications. For example, if there is a vulnerability in specific library, it can affect all of your software, all of your components, all of your products. So there is another balance between this common mechanism and also a common economy of mechanism. So yes, we need to have some kind of balance between using everything for just one thing for everything, and also trying to understand its risk and its single point of failure. And maybe the most important part, we forget about it for our users. So imagine applications created for most of time for users, whether it's human or a machine or maybe an animal. But we create applications for some kind of users. So there is no point if users cannot use your security control seamlessly. So user experience may be the most important part for the security. So imagine if psychologically, if it's not acceptable, the application itself cannot be used. And then there is no importance of security. That's why we need to understand psychological acceptability for our users as well. Okay, it's going to be secure, but if it's going to be too hard to manage, too hard to maintain, there is no point. So weakest link, it's kind of a chain is only strong as its weakest link. It's a saying that probably you already heard many times, and it's the case. So if you look at any hacking stories in the wild, you could see there is always one point, the weakest link, whether it's forgotten, whether it's maybe bad intention, whether it's not a bad intention, but a mistake. But there is always a mistake with related to weakest link. Creating weakest link, it's related to adequate security as well. If you don't have adequate security, you will create weakest link for your company or for your products. So, leverage existing components. It's another controversial topic we have in security related to economy of mechanism and also least common components. So, leverage existing components, fewer attack surface, but more spaghetti code, more complicated things. There is another balance here. So, we need to be keep it simple and stupid, but if you are trying to send a rocket to Mars, how would you keep it simple? If needs to be complicated. Sometimes products needs to be complicated, but the underlying architecture still can be simple. So we are trying to be keep it simple as much as possible by leveraging existing components, but we need a balance to see if we are creating a single point of failure. So single point of failure means that if there is something happen related to this point, it will be a failure for everybody or everything. So unfortunately, in real life, we have many single points of failure. If you think about yourself, if you think about your family, if you think about your company, you can see single point of failures all the time. When you be more mature enough your process, you will be starting to remove your single point of failure. To do this, of course, it requires some maturity, some experience to understand where is the single point of failure. Because most of time, especially in large companies, it's very hard to identify single point of failure. Sometimes you can identify single point of failure, but it's not easy to remove the single point of failure because of the complexity of the architecture, sometimes complexity of the components or the relationship between company and the security team can be different. So securing a software is very easy, is very simple, right? Of course. But how? So you can think like three main concepts. The first one, look at your attack surface, identify your attack surface. What potential surfaces do you have? And the second part, when you have the attack surfaces, identify the attack vectors can affect the attack surfaces. What potential vectors do you have? That means I have this attack surface can be affected by these attack vectors. Attack vectors sometimes can be complicated as by definition, but it means that attack vectors is the hacking maybe technique. For imagine a house has a door and a lock. So what is the attack vectors? I can try to break your door. I can try to copy your key, or I can try to find someone can open the door for you. If I can impersonate for you, if I can impersonate you to open the door with maybe a specialist keymaster. So those are the things can be attack vectors. And once you have you identified attack surfaces and you identified attack vectors, you can allocate security controls by using risk-based approach and security controls. Security controls are easy. Of course, it's easy because we have been discussing in 20 minutes. You can just implement it, right? So we have controls, but security controls can be differ. How is it? So let's try to look at. Security controls can be directive, which means it's proactive, means before the incident. So the policy is a good example. This is what you are allowed to do or you are not allowed to do. You can create a policy to dictate, to give the direction for your people or for your software or do so. And security controls can be deterrent. It means that it's not actually security control, but it creates some kind of fear, some kind of protection, but it's not itself the security control. So that means that before the incident, you can discourage people from doing something wrong. As an example, watching people with a security camera, it's not just about accountability. It's not just about recording people and trying to find maybe the theft in the recording. It's also about once they know they are under observation, they will hesitate to do some things unless they are not a professional criminals. So, deterrent. And preventative means before the incident, especially, it's still proactive. Try to stop a person from doing something wrong. For example, password is a preventative control. If you have a password, if you know this, if I don't know this, you cannot use your password. It's preventative. But itself, it's not 100% control, as like other security controls as well. And detective. So that means we are switching from proactive to reactive. Means in the incident moment or right afterwards. Trying to detect an incident, for example, having logs. You are trying to look at logs to detect something, but it's not proactive, it's reactive. Because when you look at logs, it means that it's already recorded and you cannot just go back in time and stop it, but you can monitor it. And the other one is corrective. So that means we are still reactive, means afterwards. Try to reestablish control after an incident and correct the immediate problem. So there's a problem, there's an effect or defect or something, whatever you call, but you are trying to correct the mistake and you are trying to fix the problem. And it's still reactive because it's already happened. And my favorite, restoration and recovery, and reactive one means, of course, afterwards. Everything happened, and you can see what happened, and you are trying to rebuild and get back to normal. So, implementation is tough. I'm sorry about it. Security as a concept is very easy. Using security as a tool to be more secure, it's very easy. But implementation part is very tough. So, to implement security to software, we will need secure coding practices. We will need some kind of separation of environments, development environment, maybe staging, maybe deployment environment. And also, we will need proper testing in every stage of the secure software development lifecycle. And we will need validation and discovery. We will need mitigation because it's not going to be 100% perfect. There will be some problems. And afterwards, we will need root cause analysis. Maybe the companies or people just forget about it. So there's a problem, we mitigate it. But if you don't do root cause analysis, it will happen again in different way. If you can analyze the root cause, you can understand the root and you can be more proactive to stop problems. And also, maybe another forgotten thing, documentation in every steps. Because when you don't document things, you create single point of failure, depends on people. So document it to remove single point of failure. So what are the components of appsec to do this, right? There should be some kind of tools to leverage things to do together. Of course, there are many tools, but since we are trying to do a very fast track course for application security, you can imagine like in every company or in every startup, you can see threat modeling, you can see security testing, and you can see vulnerability connection and collection and prioritization, which is project management. So for threat modeling, it's all about, we discussed before, looking at your threats, you're looking at your attack surface, attack vectors, and trying to understand what could go wrong and try to understand what kind of security controls you will need. It's all about assumptions, but you can validate later. So threat modeling can be done manual with people, and also you can automate some of the parts, but not every parts, with some kind of softwares. And the other one is security testing. You can do SAS, DAST. We have many abbreviation, and in security we love them. So SAS means static analysis for software testing, and also DAST is the dynamic one. The idea is testing your software in every step with, for example, Rasp in runtime. So you can look at your software to understand details. By the way, we also have a great detailed book about this course, so we will share the link as well. So vulnerability collection and prioritization, it's an information that coming from experience with companies that you need to do project management. Without having some kind of project management, you cannot track your vulnerabilities. Imagine you have a critical vulnerability today, you have another one tomorrow, you have another one the day afterwards. So how are you going to track this? You need to look at it, you need to fix this, you need to understand the risks, but you need to eventually collect them and prioritize them by using some kind of softwares like Jira, Asana, or Trello. Probably you heard or you already using some of the project management tools in the wild. So there will be bloat, there will be risk. You cannot stop risk, but you need to manage the bloat. But how we can do this? Of course, by risk management. We talk about residual risk, right? So you do everything for security, but afterwards there is a residual risk. So what's next? So what? You need to do risk management. There are some tactics or techniques you can use. The first one is risk avoidance. This approach mitigates risk by refraining from activities that could negatively impact your organization, which means you are trying to avoid from risk. And another one, risk reduction. You can do some kind of risk management methodology to aim limit losses rather than completely eradicate them. uh, when you have risk that you cannot remove 100%, you need to do some kind of risk reduction to reduce your risk to an acceptable risk. And you can maybe put some kind of another security things, or you can put some kind of monitoring on it to understand or spread the risk to another components. And another party is risk sharing. Sometimes there are some risks you cannot take by yourself. In this case, you just need to distribute among of the groups together to share the risk in a technical way, to not take in 100% of the accountability of the risk. And transferring risk. It's normally very easy to explain, but it's very hard to implement in real world. This is always about contractual. So you do insurance. For example, if there is a risk of fire in my apartment, I would do an insurance for my property. I would pay some kind of money for future in case if there is risk happening, some kind of fire or something, I will be transferring my risk to another company, which is insurance company at the moment. It's not easy to do this in cyber area right now. There are some companies implementing some cyber insurance for uh, companies. You could try to work with them, but it's not mature enough by today because it's a very new concept. Because it's very hard to estimate the risks potential effect to the company. So, risk acceptance and retention. You apply to everything: risk sharing, risk transfer, risk reduction measures. You do everything. But what if you have still risk? So, in this part, you just need to close your eyes? Of course not. We need to do some risk acceptance and retention. We need to find the relevant stakeholder. Who is the owner of this risk? And are they going to accept the risk? If they accept, you need to manage the acceptance. You need the retention. You need to monitor it. You need to see it. Because if there's a risk, there will be an event eventually. So, and so far, we put the expectation for ourselves to understand the language and the ground. And there are some additional points we can look at it, like vulnerability disclosure program and bug bounty. We cannot do everything ourselves. And there are some crowd methodologies that, like bug bounty. Okay, guys, I have done everything for by myself. I work with my people, appsec engineers, and third-party companies to cover everything. But still, there are some risks that I cannot see. What I'm trying to do in here, trying to put some kind of bug bounty program to attract some hackers to see if they can hack my application. I can give them money. So it's kind of like, okay, I understand you are smart. You can hack my application. That's wonderful. Please don't do harm. I will pay you to hack my application. This is the things. So before going through vulnerability disclosure program and bug bounty, it's very relevant to each other. But eventually, when there is a vulnerability, when you fix it or cannot fix it, sometimes you cannot fix some vulnerabilities, you need to disclose. You need to have some kind of disclosure program to allow people there was happening something and you have some kind of story about it. And most of time it's related to bug bounty because in bug bounty programs, we can have some critical vulnerabilities that we can fix, that we cannot fix. So it depends on the complexity. So you need to have some kind of threshold to make a pressure on your shoulder. For example, if there is some kind of critical vulnerability that that couldn't fix for 30 days, for example, I'm giving a very long time, you need to disclose to everybody because if someone you that you're that they are using your software or components or library, if there is a critical vulnerability and if you cannot fix, whether if you can fix, so you just need to let them know in a proper way. So we talked about shifting left and shifting right. There are some discussions which is best, which is right. It's very hard to define. Of course, the best scenario in ideal world is shifting left. You need to do things at the beginning of your software design. So when you try to design your software, you need to think about security, you need to do threat modeling, you need to do risk assessment. But sometimes it's not possible to do this. What about startups? What about two or three people of startups? They are just software developers trying to create a great product. Sometimes it's impossible to shift left. But what you can do, you can start from the right. You can have some kind of automated open source tools. You can use many open source tools to see if there is anything wrong with your code. Or you could have some kind of penetration testing, code auditing, or some services from companies specialized for to do this. When you getting bigger and bigger and bigger and mature enough to implement or shift to left, you could start shifting left. So of course, if we would have unlimited time, unlimited amount of money, and unlimited patience from users, we could start from shifting left at the beginning. But most of time this is not the case, and you would need to understand what is best for adequate security. So far we discussed everything we can understand from security. So what about known attack surfaces and vectors? As I mentioned before, there will be another session to discuss in detail, hands-on and code examples. But in a high level, for especially for the Polkadot ecosystem, there are known Rust vulnerabilities. For example, Rust specific issues or unsafe code or cryptographic errors. Those can affect your system or affect your products, which is if you are using Rust directly, it's not surprising, right? And also there are some non-substrate vulnerabilities, such as insufficient testing, centralization vulnerabilities, or palette-specific vulnerabilities, which is going to be very clear with code's example next week. And also, it could be related to ink vulnerabilities, such as incorrect access control, or denial of service, or timestamp dependence, or outdated versions. If you look at all of those, you can clearly see that all of those related to each other. Sometimes it's very different, but in general concepts, they affect CIA triad and the product itself. So, as a summary, it's very easy to do security, do the DEM input validation. It's good to go. Of course, it's not the case, but I have a question for all of you. Of course, there is no correct answer as my knowledge by today. So, how would you defend the castle if there is no castle to defend? People love to do some kind of comparison between Web 2 and Web 3. So, in my opinion, it's all computer science. It's all technology. We are using same fundamentals, and they need to be worked together. I don't see any Web 2 Web 3 comparisons. But if it's trending, let's try to use it. Imagine in a traditional application, there is a castle you can defend. But in the new kind of technologies we defined in Web3, so called, So how would you defend a castle if there is no castle to defend? So thank you very much for all listening to me. So we can jump into the Q&A session.
That was great. Thank you so much for that presentation. I know I really enjoyed it. I hope other folks got a lot out of it as well. And yeah, we're gonna do a little bit of a live Q and A. I don't know if Nuke, if you were talking about joining as well. Do you wanna pop on? I can add you to things here. Hi, there he is.
Hey, everybody.
Hi. So yes,
Yeah.
we have a couple of questions that have come through. The first one here is there a risk assessment template, documentation, or process flow that Parity/Polkadot uses that could be shared?
That's a great question. Yes, there is a defined process and also very well documented process. And yes, it can be shared, but not as it is, of course, because of the some of the important things that are being used in the some processes. But of course, it's possible to share it in a generic way.
Cool. And is that something then we can send out to folks like via the PBA or Heroes channels they're on? We can
Yes.
follow up. Okay, great. We'll do that. And the next question then is how could you effectively be transparent about vulnerabilities you cannot fix while at the same time deterring potential attackers from exploiting them?
That's a wonderful question. So that's why we need security people, right? So eventually blame someone. So besides joke, that's a wonderful question. So eventually, when we look at some kind of generic policies for vulnerability disclosures, it's always work like this. So if there is some kind of critical vulnerability, it needs to be fixed in X amount of time. Okay, that's wonderful. If you cannot fix, you just need to disclose to relevant parties first. So you just need to leverage the components that has been used by some companies. You don't have to directly disclose to everyone right away because it's directly to saying to hackers, hey, could you please come and hack us? But there are some methodologies and implementations can be made to reduce the risk, such as to understand maybe you can put some, for example, web application firewall. You have some kind of problem that you cannot fix, but you can configure your web application firewall for your web application to stop the exploit, or you can monitor the exploit, or you can try to distribute the risk each other maybe other components. It will be depend on mostly yes, responsible disclosure. Thank you very much, Pavel. So it needs to be done. But the question is eventually, when you disclose to someone, it means that it's out and you cannot build your security on trust of it, right? For example, we are doing some kind of responsible disclosure. We just give to relevant stakeholders, but it's out. Someone can spread the word. That's why there are there are some needs to be monitoring and trying to manage risks because eventually security is all about managing risks. So there are some very good write-ups and also industry standards from NIST especially, and also from OWASP. What is the best way to do vulnerability disclosures and how you can reduce your risk? So I would suggest you to go dive into this direction.
Great. Thank you. So let's give it a couple more seconds. Somebody got any additional questions to pop them in the chat. While we're waiting on this, we should mention that this. We got one from Dan. Well, Dan, you can read your own question. I'll put it on screen for you, but you can read it out here.
Sure. I'm curious. This is maybe a harder one. So especially in this idea of immutable ledgers, right? There might be a bug or an exploit that's put out there in the world, and people are starting to use that contract, for example, and it's broken, but it can't be fixed, right? So I wonder if you can comment on this case. Like, what are the best practices? Like, I got to tell all the users of this thing that this is broken, and if they don't get out, all their monies or whatever it might be is in peril, if not gone already.
Wonderful question. So maybe it's little bit extreme to make it everything in on chain. because sometimes we don't need everything on chain. But that's a great example in the past, which has happened in 2016. So we need to look at a software as living organism. For example, DAO. DAO, that doesn't mean only a soft piece of software. It's also meaning that there are some people behind the hood uses the DAO, and because those kind of tools are only for tools that we use to do something. So if you look at DAO, so that's why we have people need to decide to do some things. In this way, there needs to be, so if there is a smart contract that can be exploited, and if there is no way to upgrade, that's why we need people with a proper blockchain infrastructure that cannot be exploited by definition in the consensus mechanism. So the game theory itself will work and will push people to do the right thing. If they don't do the right thing, it will be a disaster for everybody. And in this case, hopefully, we are covered by game theory and the blockchain fundamentals itself. But eventually, the security question is, should we do everything on chain? What are the things we need to do on chain? And how we can remove trust without building another trust level to people with using blockchain fundamentals? Because some of the technologies like cryptography, imagine about cryptography, there are some discussions about some RSA 2048 breakable or not right now. So there are some papers out there. I don't know they are legit or not, but eventually with quantum computing, we will start uh, using or seeing some kind of problems related to blockchains as well. But eventually, the thing is that if you have the correct game theory, if you have the correct security process, it's possible to reduce the risk. But there is no zero risk if we are using smart contracts. If we are using smart contracts, we should be able to understand there's a risk that there will be an exploit maybe anytime. Thank you very much for this question.
Hopefully that covered it for you, Nuke. We have another question coming in saying, do you consider black swan events in your risk assessments?
Another great question. It depends on the, yeah, sometimes presenters when have a hard questions, the answer is always start with it depends, right? So imagine like an interview. So it depends on the scenario and it depends on the time. So it's always what is the risk, what is the impact, and how we can reduce the risk and what kind of resources I have. So do I have some kind of security army, for example, 20 people with me to do risk assessment, and I have unlimited amount of time and unlimited amount of money, or do I have only one security guy needs to do risk assessment for 100 products? It depends on the situation I'm in or the security guy in. In this way, we can decide, okay, so this is the most critical product, this is the most critical scenarios. Let's try to do things we can do. If there is time, if there is resources, of course, we can include those. We should actually, maybe we must.
Great. So give a couple of seconds to see if any more questions come through. Also, we probably should talk a little bit about kind of the organizations bringing these workshops and these different streams through. I know Nucleus is part of this is number one in a series, I think, of 3 different streams that are going to be happening. Is that right? Do you want to talk to us a little bit about the other 2 that are coming up?
Yeah, I think our awesome presenter here is the first of a few more from the Parity Security team who will be doing some things related to this topic, right? Which is so mission critical in our field in particular. So I'm very excited that this can be part of, as you'll notice, like on that slide ticker up there, the Polkadot Blockchain Academy. So this is part of the coursework that you'll be able to see now and come in person and get far, far more than this. And I believe our next wave is going to be in Hong Kong, right, in January. That's coming right up. I think applications have closed or are very close to if you're watching this now. And then Singapore in the May timeframe, spring, and who knows beyond that. We'll see. But there's a lot of quality content around learning how to do Web3 development in general, specifically around blockchains and Polkadot as a product to use to do this kind of stuff. So I think overall, the Academy is a great thing to check out. And I'm really excited that we can have such wonderful people to come and educate us about these topics in this light. So yeah, I think maybe Sharon, you could speak to what's the next two that we have on the plate.
For sure. So maybe probably the next one and the other one the most important from then this one, because this was all about creating the ground to play together, and the next one will be about top security risks, about Polkadot and Substrate with code examples. In this way, you can see the what can go wrong with codes and what you should do to implement in a secure way with the things we have seen so far. Because we are talking about risk management and how we can do some security controls. There are some security controls, but how would you do this in Rust, for example, in Substrate, in Polkadot? So we will see in deep dive in the next session. And the other one will be in infrastructure part. So our applications needs to be live on somewhere, right? Which is the infrastructure. So of course there are some blockchain infrastructures and other things, but let's accept that we need to use most of the cloud services. We need to use some of the open source tools or the commercial tools to deploy the applications. So maybe the last part, the most important, another part is that, so how would you put a secure infrastructure to build your applications on top of it?
Nice. So we have a couple of questions coming actually around PBA as well. I'm going to take this most recent one here. The how much Rust you need to be able to clear the PBA exam is. I was in cohort 2 at PBA in Buenos Aires, so I've done the PBA exam, not the most recent version of it, but a version of it. And I will say the better you are in Rust, the more you'll get out of the actual course itself. It wouldn't really be something that I would say just learn this amount and that's enough to get you through the exam and then you can stop. It's the better prepared you arrive at PBA, especially with your Rust experience, then the more you'll take out of it. There's not enough time in the academy for somebody to learn Rust and then also to learn everything else. So if you're spending a lot of your time learning Rust, then you're not going to get as much out of the academy as you possibly can do. Now, that said, if you check out the PBA organization on GitHub, there is the actual examination itself is open source now, I do believe. So you can go and you can test yourself there to check what your understanding of it is. I would recommend at a very base level, beyond everything I just said there, by making sure you get as much experience as you possibly can. If you're looking for like what is the base that I need to have, I really enjoy the Brown University version of the Rust book, as that also has exercises built into it as you go through it. I'm just going to get a link for folks now. So you can actually go through and test your own understanding of Rust as you're actually learning it from the Rust book. And in that one, I would recommend not just to pass the exam, but to give yourself a good chance of understanding Substrate and Frame, etc. That you really need to cover everything in that book up to, I would say, at least chapters 1 to 11. And then probably chapters 18 and 19 as well. So if you can cover everything that's in those and have a really good understanding of them, you'll have a good chance of not only being able to pass the exam, but also being able to work efficiently with kind of Substrate and Frame. Also, obviously, the Rustlings is a good resource as well that you can take alongside reading the book. So yeah, I would recommend kind of those if you're just getting started with Rust to get some experience to be able to take the exam and possibly qualify for PBA. But I would suggest not just working to that exam, like really do try to be as familiar as you can possibly be with Rust, and probably even Substrate. Get a little, like, I know it's kind of skipping ahead a bit before PBA, but you will get so much more out of your time there if you're ready to arrive a little bit prepared, so you can talk to the instructors, you can talk to the faculty and the TAs and things, and not just have to just learn the framework, but really be able to make the most of your in-person time with them and get to know a lot deeper into the topics.
Yeah, 100%. I would also say that I think relatively soon, although I don't quote me on this, we'll be publishing the assignment 0. So this is like, you passed the exam and we'd like you to be at the academy. And then there's more nuanced work around what basically, like, you get to design a mini cryptocurrency in Rust using this deeply nested traits and generics that we see a lot in Substrate. It's very similar stuff. So I think that if you're going to prepare once you're coming into the academy, if you're much more familiar and actually hands-on code, not just reading code, like writing some of this stuff, you're going to do a lot better, because some of the syntax is peculiar, especially if you're new to Rust. It's like, it took me months, maybe I still am not all that great, like years of practice at this stuff, and then you'll understand what they're trying to get after.
Mm-hmm. And also, I just want to give a shout out as well. Like, if it is something you're interested in and you want to find a community even before you go to PBA, there is the Developer Heroes program, which is open for like anybody to join. You don't need to be somebody who's super experienced in Polkadot right now. You can join as a rookie, looking for a mentor, like looking for one of the heroes in the program to mentor you. With the hope then eventually that once you have the experience and knowledge, that you'll stay on and become a mentor yourself. But yeah, you can join the program as somebody who wants to be a mentee, and is looking to get some help with their Rust, with their Substrate before they even go to the academy. Of course, obviously, any PBA alumni who is watching and would like to join the Heroes program are more than welcome too. But yeah, it's not a requirement to have a lot of experience before you join the Heroes program. Okay, well, unless we got any further questions from folks, I think we're going to call it for today. The next one is, remind me, I think it's November 15th. Is that right? I think that's right, Nuke, isn't it?
Next Wednesday. It'll be fun. What's the topic we're doing one more time?
Oh, very good question. I'm going to look it up right now.
I'm looking at him. Maybe not. More security topics. It'll be good. And I believe more code-based. Yeah. So we should be seeing some more of the things that we're talking about, like Rust, and specifically security-related Rust topics. So it'll be fun. Sign up today. Yep.
So there is the registration link I've just popped in chat. So folks, go register for next week's stream, and we will see you all there.
Thank you.
Have a good one, everybody. Thanks again. Bye.